Hi Adessa!
Hi Rai, how are you?
I'm all good. How about you? Are you ready to talk with some modern physics stuffs today?
I'm good. And yeah, it is a great opportunity to have someone to talk to about the modern physics. You know, it was really challenging to learn this branch of physics.
Indeed, especially in our situation today where we can't have a face-to-face discussion with our instructor. So we really have to try our best in learning it independently. However, here we are, we survived.
Yes, you're right, Rai.
So let's talk about first with relativity and simultaneity. What are your thoughts about this, Adessa?
Well, for me, modern physics actually talks about the events and its measurement of space and time, which are relative to each observers. And talking about relativity in this topic, I have understood that we are also dealing with simultaneity, relativities of time, length, and velocities. By the way, I personally relate the word simultaneity to the word simultaneous, though it is really pretty lame, but it helps him better and easily remember the concept. So going back, I have understood that this simultaneity describes something or two things occurring at the same time, while relative is something that is not absolute.
Yes, in order to understand it, I really have to accept that absolutes first. You know, absolute that we need to accept, like, there's no such thing as absolute at rest or absolute motion because when we talk about relativity, object moves relative to each other.
Also, relativity refers to the context where things are different for different observers. The word relative itself meaning it things depend on other things. That is, for instance, I view things this way while you view it that way, given that we are in different place or something. If we join these two terms, we can come up to the idea that relativity of simultaneity refers to the two events occurring at the same time, observed by two observers, which are at two different reference points. We'll observe different or two simultaneous events in relative perspective. Simply, for instance, when two events that are objectively occurring simultaneously, observer A and observer B will have different perception based on their frame of reference.
Yes. As we all know, Einstein's theory of relativity have two principles. And according to my understanding too, that the thing you have said a while ago, which when two events that are objectively occurring simultaneously, observers A and B will have different perceptions based on their frame of reference. I think that falls under the first theory, which states that it is not possible to tell whether which object is moving and which object is at rest. So here it is that the idea or the concept that no object is in an absolute motion or absolute rest enters. So the perspectives of both observers are equally correct, whether they think that they are the one at rest and everything around them is moving.
That's right, Rai. You know what? This is so great. Sharing of ideas broaden our minds. Imagine we have different ways of understanding the topic, yet the thought is still there.
That's what I'm seeing too, Adessa. Hey, are we going to talk about time dilation, length contraction, and time travel?
You look excited, Rai.
Of course, we'll not get so excited with this one. I can't forget how amazed I am upon knowing that the speed of light is the same for all observers and it is observed in time dilation. Am I right?
That's right. Relativity of time is observed as time dilation, or the time interval between two events measured by each of the two different inertial reference frames moving relatively. We already know that the dilated time is determined by getting the quotient of the proper time value and the square root of 1 minus speed squared over the square root of the speed of light.
Speaking of formula, we must not forget that the proper time is the time measured by an observer at rest relative to the event being observed.
Thanks, Rai. By the way, moving on, another concept that I have understood is all about the relativity of length, where objects moving in a relativistic speeds undergo a length contraction. Do you have any thoughts about it, right?
Oh yes, length contraction. This is where when object moves closer to the speed of light, not only that the time slows down, but the object itself contracts. I was having a hard time in calculating that one, though everything's fine now.
Yeah, well, that's good to hear. Well, the most important thing to remember in this concept is that contracted is always less than the proper length. And we use the formula contracted length is equal to the proper length times the square root of 1 minus speed square over speed of light squared. Honestly, I also have had a hard time with this one, especially in determining whether the value is a proper time or the dilated time and the proper length or the contracted length. So I made a note that the Earth will experience dilated time and measures proper length, while the one on the ship experiences the proper time and measures the contracted length. And guess what? It works just fine so far.
I see. Learning modern physics as well as solving problems about it is a matter of your own strategy indeed.
I agree. Anyway, the last concept on this topic is the relativity of velocities. This concept was quite puzzling for at first, but eventually I understood the concept bit by bit. Based on what I have understood, we are taking into account two relative velocities that is determined using the formula of the particle measured by the observer at rest, which is equal to the sum of the speed moving particle moving in x direction in the first inertial reference frame and the speed of the particle moving parallel to the second inertial reference frame over the sum of 1 and speed moving particle moving in x direction in the first inertial reference frame times the speed of the particle moving parallel to the second inertial reference frame divided by the speed of light squared.
I have nothing to add on this one since you have already got it all. Just kidding though. Anyways, just like you, I really had a hard time understanding this one too, but then little by little, I cope up with it. The formula and or the calculation steps you've said are right, Odessa. Now I leave one learning on this topic. Through relative velocity, I've learned that there is no answer in a question, how fast is something moving? Because it's all relative. And maybe that's all for today. I've enjoyed a lot. It's really nice talking to you. I did not only share my knowledge but also gained new knowledge from you.
I really have a great time as well in talking to you about these things. I hope that aside from us, they have also learned a lot by watching this video. And that's all for today's video. Again, this is Odessa and my partner, Miss Raimi Lanaban. Thank you for watching.